Oh, share. Sorry, excuse me. I'm still trying to use this. Oh, why? I don't know. Well, all of a sudden something not working. What did I do? Sorry, look, I got a problem now. Just a minute. Give me a second, guys. I'm trying to sort out something. Okay, so why can't I show this? I mean, oh, okay. Here we are. Okay. Okay. Thank you. Now it's working now. All right. So what I'm gonna do now, guys, is sorry. I'm gonna do some examples. Okay. Starting with a simple example. Example 1. So after the end of this session, what I will do is I will copy everything I have written and put it on the course website. I did the same yesterday, but initially I ran into some problems yesterday, but eventually I managed to sort it out. I hope you guys looked at what we did yesterday. Okay. Can you see my writing, guys? So we have a random sample from a normal population with parameters mean equal to theta and variance equal to 1. And the problem is to find the confidence interval for theta. Okay. Okay. So how do we go about this? Right. The first thing you should realize is that we should have a random sample from a normal population, right? Then x bar, the sample mean, should have the following distribution. I mean, this is one of the things I talked about. You should look at my notes on the number distribution. You will see it, right? Okay, so x bar must have this distribution, which implies that x bar minus theta must have a normal distribution with parameters 0 and 1 over n. Okay. Okay, guys. So this implies that x bar minus theta divided by 1 square root of n as a normal distribution with parameters 0 and 1. Okay. Are you following me, guys? Let me know if you're not. Okay. So because this has a standard number distribution, um, if you remember the picture that I showed you some time ago, right? That because this has a standard normal, the probability that this guy here, x bar minus theta divided by 1 over root of n, this must be 1 minus alpha. Yeah. You follow me? Okay, so that means if you rearrange this equation, you get this, okay, right? And if you rearrange this further, you will get x bar minus z. Right, this is what you get, okay? And in the next step, I'm going to use the following fact that I think I mentioned this in the class that you probably remember, all right, using the fact that z alpha by 2 is equal to minus of z 1 minus alpha by 2, okay? That's because of the symmetry of the normal distribution. So using this fact, we can write the above statement as equal to 1 minus alpha, all right? So we have come up with a statement which gives a confidence interval for theta. So the conclusion is the following, guys. So hence 100 times 1 minus alpha confidence interval for theta is the following, is the interval. So it's an interval on the real line with the low limit being this being the lower limit, and this being the upper limit. Okay, guys. So that's example 1. Are you okay with this example, or do you have any questions, guys? If you have any questions, you can use the chat room. Now there's a chat room for the Zoom, and you can type your question. You can type your question on the chat room. Okay, so let me check the chat room whether you have any. Okay, one question I have is, can we estimate the CI using integration? I really don't understand what you mean by this question, but it's not okay. I mean, the question is, this is the confidence interval for the population mean data, and of course, everything here is estimable because x bar is the average of the data, n is the sample size, and z 1 minus alpha by 2 is you can read it from the table. So there's nothing in this formula. There's nothing in this formula that you cannot estimate, right? So everything in this formula is estimable, right? So there's no question about there's no question about whether you can estimate or not, because everything in this formula is estimable, right? Okay. Okay. The next. So this is example 1. Now the next one I'm going to do is example 2. There are only about 25 people listening to this. I would like to see more of you joining the Zoom session, because I don't know, because there are about over 300 students in this class. So maybe some of them have gone back to China. I don't know. Maybe it's difficult to connect to Zoom from China, I guess. Anyway, all right, let's look at example 2. Okay, suppose example 2, all right, you have a sample from a normal population with mean equal to 0 and variance equal to theta squared, and we want to find a confidence interval for theta. All right. So how do we do this? So to do this question, to do this example, we need to use one process that I talked about in the class. You may remember that this is also what I talked about. This is one of the results I talked about in the class. You should look at my notes on the chi-square distribution. You will see that this is a result I mentioned as a property of the chi-square distribution, right? Okay. All right, guys. So this implies the following: that the probability that no, okay, can you see? Okay, so the probability that this lies between cannot see my writing, please let me know. Because suddenly, I mean, the Zoom is not the, it's a good software, but sometimes it plays around. So sometimes you may not be able to see what I write. So if you cannot see what I'm writing, please let me know. All right, so this implies that the probability that right, so this probability is equal to 1 minus alpha. All right, guys. So this implies further, because theta must be a positive. Remember, theta represents the standard deviation, so it must be a positive number. It cannot be negative. So this implies that the probability that
I can learn to understand.
oh, sorry. Okay. So this what I've done is to take the square root sign on throughout the inequalities, so you get this. So the conclusion is the following: that hence 100 times hundred times 1 minus alpha percent confidence interval for theta is just the following: that the lower limit is the limit from the limit from this is being the lower limit, and the upper limit. Oh, sorry, my handwriting is getting worse and worse every day. Excuse me, guys. So the upper limit is this one. I from 1 to n of xi minus x bar squared divided by chi squared n minus 1 alpha by 2. Right? So this is the conclusion for example 2. So this is the confidence interval for theta when you have a random sample from a normal population with zero mean and variance sigma squared. Sorry, variance theta squared. All right, guys. Any questions on this, guys? Let me know before I do the next one. So let me do some more. If you have any questions, just please please write to me in the chat room. Thank you. Where is the sorry, okay, the next example I'm going to look at is the following: is the what's going on? Just a minute, give me a sec. No, not this one. Stop. Sure. Oh, sorry. Okay, here we are. Okay, that one. Sure. Okay, thank you. Thank you for being patient with me. I'm just still trying to experiment. I'm still trying to experiment with the Zoom thing, so sometimes it does weird things. Okay, the next example I'm going to look at is the following. Example 3. Okay, example 3 is the following. Suppose all right, so you have a random sample from a uniform distribution with parameter from 0 to b, and we want to find a confidence interval for b. This one is a little bit tricky because it involves a uniform distribution. So the first thing you should try to do is try to find a function of the data that you can try to use. Okay. So all right. So let me try to show you how to do this. All right. Let Z or Z denote the maximum of the data. Now, what I'm going to find is, the first thing I'm going to do is to find the CDF. CDF of that is as follows. I think I've done something similar to this before. You might recall this. And this is equal to the probability that the max of x1 to xn is less than or equal to z, right? Come on, what's going on? All right, so now if the maximum is less than z, then each element has to be less than equal to z, right? So x1 has to be like this, all right? And the next step, I'm going to use independence because the assuming is IID. Remember, IID includes independence and identical, right? So using independence, you can write this as you can write it like this, right? And in the next step, I'm going to use the fact that they're all identically distributed. So this will be the probability that x is less than or equal to z power n, right? Okay. Now we are assuming that x is uniformly distributed from 0 to b. So this will be power n, all right? Okay, guys. So that's the CDF of the uniform distribution, right? Okay, now let me show you. You should actually plot this. This is why my plotting skills gonna. Let me try my best here. So what I'm doing here, guys, is I'm trying to plot on the y-axis this, and on the x-axis this. Okay. So your graph. Okay, let me use a different color. Your graph will look something like this. This is 0. This is 1, and this is sorry. Let's say this is B. So your graph is gonna look like something like this. So it will be. So what I have plotted here, guys, is the graph of f, the CDF of z versus z, right? Okay. Now what I'm going to do is I'm going to construct a confidence interval for B, right? So for that purpose, you need to split this graph into three little regions. So, and this region here, this region should have an area of alpha by 2. Okay, and this region here should also have an area of alpha by 2, right? So the area in the middle, which is this, will be 1 minus alpha. Okay, you follow me? I'm trying to use the color facilities here, and this area is alpha by 2. This area is alpha by 2. So the area in between, the area in between the 2 points, that is this point here and this point here, is 1 minus alpha. All right. Okay. Now the question is how to determine these 2 points. So the question is how to determine this point here and this point there. So that's what I'm going to look at now. To determine this point here, yeah, we need to set the CDF equal to alpha by 2, because remember, alpha by 2 is this area here. This area here is alpha by 2, right? So the area to the left of it is alpha by 2, right? So we set the CDF equal to alpha by 2 and solve for Z to get this point, right? So that's what I'm going to do now. So this becomes and so this becomes okay. So that's this. All right. So what I have, so the answer to the question is that this point here is equal to b times alpha by 2 raised to the power 1 over n. And similarly, we must ask the question about this point here. So if you go up just a little bit, this area here, is this area is alpha by 2. Okay. All this area here is alpha by 2. Right. Now we want to determine this point here, what the value of this point. So determine the value of this point. What I'm going to do is the following. So I'm going to draw arrows, big arrow here. All right. So okay. So you can see now to determine that point, I'm going to set the CDF equal to the area to the left of it, which is what? The area to the left of this point is 1 minus alpha by 2. Okay, so this implies that Z divided by B power n is 1 minus alpha by 2. So Z divided by B. Hello, are you talking to me, sir? So Z to 1 minus alpha by 2 raised to 1 over n. All right, so what the thing I want to so far is the question. So what I have answered is I have figured out the 2 coordinates, the coordinate of the white, the point to the left and the point to the right. Okay. Okay, guys. So the probability. That, let me zoom it in again. So what this implies is that what I have answered is the probability that that Z or Z lies between this one and this one is 1 minus alpha. You see that? Do you see that? This is true because you should go back to the diagram. You should go back to the diagram, which is this one. I know it's little, but the 2 white points make the area of 1 minus alpha. So the probability that the capital Z lies between the 2 white points is 1 minus alpha. That's what I'm saying. Okay. Now this you can rewrite as follows. You can rewrite this as an expression on Z, right? Okay, so this is gonna be Z times 1 minus alpha by 2 to the power minus 1 over n. It's equal to this, right? Hence, so we have answered, hence, power minus alpha percent confidence interval for B is the following. To the left, Z is actually the maximum of all the data. And on the right is the capital Z times okay. All right, so this is the confidence interval for B. Or in other words, if you put back the actual expression for Z, which is the maximum, so remember, it's the maximum of xi multiplied by 1 minus alpha by 2, and the maximum of xi alpha by 2. This is the confidence interval for B, and so it completes example 3. I know it took a while, but so this example is a little bit different from the previous ones we looked at. Do you have any questions on this, guys? I know we are approaching 12 o'clock now, so do you have any questions? Hello, guys. I would like to see more of you joining us. There are only 24 people joining so far. Can you guys ask your friends to join? Okay, good. So, all right. So the next session, guys, is gonna be from 12 to 1 o'clock, which is gonna be a tutorial. So it's gonna be a tutorial based on example sheet 8. So if you could look at the tutorial sheet number 8, which is on the course web page, right? I will go through the questions starting in, say, give me about 5 minutes, because you may want to get a cup of coffee or something, or tea or coffee, whichever you like. So give me about 5 minutes. After 5 minutes, I will start going through the tutorial sheet, okay? All right, so yeah, it's the same as the one we did yesterday. Yes, it's the same as the one we did yesterday. But if you were not here yesterday, we can go through that again, because I don't know whether all of you guys were here yesterday or not. I don't know. So yeah, so it'd be good to go through that again, because I don't know, it depends on your I don't know the session that you're assigned to, because some people, I know some people belong to a different session like the tutorial sessions are not the same for everybody. So so give me about 5 minutes, and after 5 minutes, I will start doing the example sheet number 8. Okay. Yes, sir. I'm the lecturer. I'm doing all the tutorials myself, because yes, I'm doing the tutorials for. I'm the lecturer for all the tutorials. You remember there are 5 different tutorial sessions. And I'm doing all of them because I don't know what happened to the other guy. Maybe he's gone home. So the tutorial starts in about 3 minutes time.